Alright, so the next stanza, problem 7 and 8, they actually can be reviewed in R5. Here is a section that I definitely, the other ones probably got some bells rung or had a lot of aha moments with just some basic algebra and some polynomial work. But factoring polynomials is a huge skill. So if there's one section that I hope you guys really take a look at and practice your skills, it's the skill of factoring, because it's not going to go away. We're going to use it quite a bit throughout our semester. And so again, to factor a polynomial, what I'm asking you to do, whether it's A, B, C, or D, or anything below, is I'm asking you to break this up into a product. That's what it means to factor something in the first place. So what times what creates this trinomial? Right? What times what creates this four-term polynomial? This trinomial and this sum of cubes, if you would. Right? Since we kind of saw that up above in the last example. So that's the idea. And so to kind of give a long story and make it really short, when we're doing polynomials that are trinomials, you actually have two ways to do a trinomial. I'll show them both. One is called guessing and checking, and the other one is called what I call force grouping, or what's famously known as the AC method. So you pick what you want. I like the guess and check method. That's what I prefer. But a lot of you might like the AC method. Both of these are grounded in good mathematics. So if you have to relearn them, please do so, because this is the way I'd like you to see things done. So guess and check. Basically, what we're doing is we're reversing the FOIL process. The guess comes with the F and the L. And then the check comes with the O and the I. So I'm in control of F and L. So when I look at this first term, I'm going to ask myself, what times what gives me x squared? Well, that would be x times x. And then I look at the last term. What times what gives me the last term? Well, positive 9, that would be a plus 3 and a plus 3. So right now I have what's commonly known as a good guess. My first times my first is my first, and my last times my last is my last. To check, I just simply have to look at the outer and the inner. So in this case, my outer is 3x, my inner is 3x, and that combines to give us a positive 6x. And unfortunately, we're looking for a negative 6x. So that means my guess was wrong, but going back to the drawing board, x minus 3 and x minus 3 will probably be the choice. Again, it's another way. First times first is first. Last times last is last. The outer and the inner give us a negative 3x and a negative 3x combined up to negative 6x. So there is our answer. Of course, if you wanted to, you could write that as x minus 3 squared, since it's the same factor multiplied to itself. So that's what a guess and check looks like. Pretty easy example on that. The next one's the AC method. Again, we could have used guess and check here. Some of you probably are already guessing and checking and got it right. But the AC method, this is what this would look like. Of course, you could have used it up here as well. So when I'm going to AC here, I got to first figure out who's A, who's B, and who's C. So in this case, A is 2, B is 5, and C is negative 3. So as the method suggests, I got to look at AC. So in my case, AC is 2 times negative 3, which gives us a negative 6. So I'm looking for two numbers that will multiply up to that AC, but add up to the B. All right, so A and C create the number I need, and then B comes into play when I'm trying to find that guess. So what two numbers multiply up to negative 6, but at the same time add up to 5? All right, and I think negative 1 and 6 are basically the two numbers that we do, right? So if I multiply them, I get negative 6. If I add them, I get positive 5. So now that we find those two numbers, here's what's going to happen with them. I'm actually going to leave the first and last terms alone, and I'm going to rewrite the 5x. I'm going to rewrite it as, that's an x squared, negative x plus 6x. Mathematics is full of equivalency arguments. So even though this is a four-term polynomial, if I was to add up the two middle terms, what I would get is the middle term here. So this four-term polynomial is equivalent to the one that I have there. Of course, once I have a four-term polynomial, the method we now use is grouping. So I group by putting parentheses around the first two. I'm grouping around a plus sign, so I can keep that. And then it's basically looking for a GCF. Here we have an x, so what's left is 2x minus 1. Back here, what's common is a 3. What's left is 2x minus 1. And then when you look at these two guys, the 2x minus 1 is now the GCF. So I'll factor that out, and what's left is x plus 3. So there would be the product, 2x minus 1, the binomial 2x minus 1, times the binomial x plus 3, creates, right, that three-term polynomial. Of course, some of you probably could have got that just by guessing. It would have been done a long time ago. This is the faster method if you can guess right away. This method obviously has a lot of steps to it, but it's a good way to find it. By the way, if you can't find two numbers that do what they're supposed to do here, you're dealing with a prime number. So that's kind of an advantage of the AC method. So just play with both and get familiar with both. Again, I'm hoping a lot of you will just turn to the guess and check method because it is pretty fast and easy. For the next one, we have a four-term polynomial. So as we saw here, the way that we factor a four-term polynomial is by grouping. So that's done by grouping the first two terms plus grouping the last two terms. All right. So again, equivalency, if I was to add these, I'd get that polynomial back. Now looking at a GCF, well, what's common between these two is 3x squared. And when I factor that out, I think I left with an x minus 2. And then over here, what's common is a 4 and an x minus 2. Now what's common is the x minus 2, so I'll factor that out. And what's left behind is 3x squared plus 4. So there's my product. So those two binomials, these are the two things I would multiply to get that polynomial up there. D, as I've mentioned, as we saw before, it's what we call the sum of cubes. And the only way to factor a sum of cubes is to remember the formula. A cubed plus b cubed. The two things that create that are a plus b, a squared minus ab plus b squared. And your a and the b are basically the terms that are being cubed. So when I look at this, 8x cubed, well, that's 2x cubed. 27 is 3 cubed. So there's your a and there's your b. So to factor this, I just basically replace my a, 2x, my b, which is 3. We're going to square the a, so if I square 2x, I get a 4x squared. When I multiply them together, right, 2x times 3 is a 6x, and then 3 squared, right, b squared gives us a 9. And so there's the two things that multiply up to get that. As a matter of fact, we knew that because if you go earlier in the last video, when we multiplied 2x plus 3 to 4x squared minus 6x plus 9, what we got was that difference, that sum of cubes. So that kind of verifies that we're doing is right. And unfortunately, like I said, the sum of cubes and the difference of cubes, you got to memorize those. All right, that's the only way to really kind of get those down. Okay. Last but not least, for again R5, is this concept of completing the square. When we try to complete the square, what I'm trying to build is what's commonly known as a perfect square trinomial. And right now, x squared plus 6x only has two terms in it. So I want to be a trinomial and I want to be a perfect square. Well, the way that we do that is we first of all make sure that the lead coefficient is 1, which I got. Second thing I need to do is take that 6, divide it by 2, which gives me 3, and then I take that 3 and I square it, giving me 9. And so to complete this square, to complete this this binomial, to make it a perfect square trinomial, I have to add 9 to it. And of course, if we go back to factoring, this would factor as x plus 3 times x plus 3, or otherwise known as x plus 3 squared. Perfect square trinomial. So completing the square is a pretty important process, and we're going to see that a lot more often. So there's basically a real quick idea of how to do that. So again, to get your memory jogs, to practice these skills, which I highly recommend you do because factoring is going to be a very big skill for us, you want to look at R5, right, R.5 as your review in my math lab. Okay, so let's cut to another video to do more stuff.